let's make a sketch of a couple exponential growth graphs by plotting 2 points to get started. So I gave you in class a couple easy points you can use. This will work as long as there's no shifting going on in the graph. So 0, comma a, which we'll talk about in a second, and then 1, comma a times b. So that's an easy shortcut way to find a couple points, although honestly what I would probably do is just use the table feature on my calculator to find a bunch of points. So if you know how to do that, and hopefully you do, I'd recommend just using the table. If you're not sure how to do that, then ask me in class. So let me show you how we can use these 2 points though to find, or these 2 shortcuts to find a couple points. So first thing to be careful of is that 0, comma a problem. 2 is not your a value. 2 is actually the base, the number with the exponent. The a value is the number in front, which I don't see in this case, so I may want to throw a 1 times in front so I can see that a value. So right off the bat I try to trick you, so be careful of that. So anyway, doing 0, comma a gets me 0, comma 1 as a coordinate, and if I think about why that works, imagine plugging in 0 for x. Well, 2 to the 0 power is just 1, and 1 times 1 is of course 1. If I try that other shortcut, I've got 1, comma whatever a times b is, so 1, comma 2 as a second point. So that's how that shortcut works. You're welcome to use it, although it doesn't work if you shift the graph around, and like I said, I would probably just plot points. Or I'm sorry, use the table on the calculator to find points. So let me graph those 2 points. So 0, comma 1 would be right there, and then 1, comma 2 would be right there. Now in addition to those 2 points, there's a third thing I told you guys to graph, and that was the asymptote, the line that the graph gets really, really close to but never quite touches. Now once again, because there's been no shifting, that asymptote has not changed, and it starts at y is equal to 0, which is the x-axis. That's what I was trying to say. So I'm going to draw on that dashed line right at the x-axis. It's the line that the graph will get close to but not touch. Okay, so those are the 3 things I want to see for every graph before you graph it. Now at this point, some people see the 2 points and they think it's going to be a line, but we know better than that. I mean, any 2 points you graph would look like a line. We know the basic shape of these graphs. It's going to be something that's really close to the asymptote, never completely flat, but close to it, and it's going to curve through those 2 points and then never go completely vertical, but it's going to get pretty steep. Add a couple arrows because the graphs do go forever in both directions, and make sure that your line, your curve, does not cross that asymptote. So there's a very lovely looking exponential growth graph. Okay, the other part of my directions though said to state the domain and range. So let me go ahead and do that as well. And actually I'm going to do 3 things. I'm going to do dr and then a for the asymptote. Well, your domain for an exponential growth or decay graph is always all reals. As we talked about in class, you can make the exponent anything you want it to be, or think about the graph going forever in both directions. It never ends left or right, so it's all reals. We've already discussed what the equation of the asymptote is. It's y equals 0 because it's not been shifted. I'm picky about details, so make sure that that's an equation. So and an equation of a horizontal line, so make sure the y equals 0 is in there. And then finally for your range, that's how high or how low the graph goes. Well, the range is associated with y, and in this case I can see that the graph goes up forever, but it doesn't drop forever. Remember, it can't cross that asymptote. So my range is going to be y is greater than 0, not greater than or equal to 0, but just greater than 0. Notice those 2 numbers are the same. They're both zeros, and those 2 numbers will always match each other. They may not always be zeros, but they'll always match each other. Okay, so there's an exponential growth graph. At this point, I guess I want you to try that second one on your own. So plot a couple points, draw on the asymptote, and one more time, find the domain, range, and then write the equation of the asymptote. If you want to see my answer pop up, it'll do that in about 30 seconds, or like 2 seconds. One thing I forgot to ask was whether the second graph would be growth or decay, and while a lot of people try to say it's decay because they see that 1 half in there, remember the number we look at is the base, the b value, the number with the exponent. Because that's a 4, a number bigger than 1, this is still going to be a growth graph. So here is what my graph looked like. Notice I did the a comma b, or the 0 comma a trick and 1 comma a b trick, although I'd recommend you just find 2 points using your table. Notice the graph looks very similar to the one we just did, and the domain, range, and asymptote are still the same thing because nothing has been shifted around.